Welcome back. In the previous video, we added a mesh to our character class. Now we have the Bellica skeletal mesh, but she isn't animated, so we're going to create an anim instance in this video. Typically in Unreal Engine, to animate a character, you create an animation blueprint. You do this by right-clicking, going to Animation and Animation Blueprint. But the animation blueprint is based on a C++ class called anim instance. We're going to create the C++ class so we can have access to the native code behind the scenes. Then we can populate variables from the C++ side and then use those once we create our animation blueprint based on the anim instance class. So let's get started. In the C++ class's shooter folder, let's right-click and create a new C++ class. Now up here, check the checkbox to show all classes, and we're going to type in anim instance. Now choose anim instance as our base class and click next. We're going to call this shooter anim instance. Go ahead and click create class. Okay, so we've now created the shooter anim instance class, and we're going to add a public section to this. And we need a couple of functions right off the bat. First, we're going to override the virtual function virtual void native initialize animation. This is inherited from the anim instance class. This is an override. Now this function is kind of like begin play for actors, only it's for the anim instance class. This is where we can initialize our member variables. Now we're also going to create a function called update animation properties. Void update animation properties. And it takes a float. We're going to call it delta time. This will behave much like our tick function in actor classes. We're going to give it a uFunction macro, blueprint callable, so we can call this from the event graph in the animation blueprint. Now the anim instance does contain a built-in function that sort of behaves like tick, and it's called native update animation. We're going to create our own update animation properties and call this every frame from the animation blueprint in the event graph. Let's go ahead and define these. Visual Studio can give me an automatic definition for native initialize animation. Because IntelliSense isn't giving me the option for update animation properties, I'm just going to copy the function header and paste it in the CPP file. So I'll give it a function body and make sure the function name is fully qualified with the class name. Now we want our anim instance, and thus our animation blueprint, to have a variable that holds a reference to the character. So we're going to add that here in shooter anim instance.h. Let's create a private section, and we'll forward declare the class a shooter character and create a variable called shooter character. We'll give it a uProperty macro, and we'll make this visible anywhere, blueprint read only, and we'll put it in the category movement. Now we want to access this from blueprints, so we'll give it the meta equals allow private access equals true. So that way we'll still be able to access this in blueprints and use the blueprint read-only uProperty macro specifier. Now we need to make sure that we actually have a reference to the character, because as it stands, this is just a pointer that points to nothing in particular. So here in the CPP file, in native initialize animation, we're going to initialize this. We're going to say shooter character equals, and we're going to use try get pawn owner. Now this is a function that gets the pawn that owns this anim instance. However, it just returns a pawn, so we need to cast it to a shooter character, which in this CPP file, the compiler will not recognize without the include. So let's include shooter character.h. And this try get pawn owner, we're going to cast this to a shooter character. So we'll say cast to a shooter character. And what we're casting is try get pawn owner. So the call to try get pawn owner should return a pawn, and then we'll cast that to a shooter character and store that address in the shooter character pointer, which we have exposed to blueprints since it's visible anywhere, blueprint read only. Now, this is called in native initialize animation, but every single frame we're potentially going to access this. So each frame we need to first make sure that it's not a null pointer. So we can say if shooter character is null pointer. And in that case, we need to actually call try get pawn owner, cast it to shooter character, and populate the shooter character variable. So we'll copy this line and we'll paste it in this if statement. So any given frame, if shooter character is null, we'll try to get it again. Okay, let's add a few more variables to the header file. We're going to want a float variable for the character's speed. We also want a Boolean to tell us whether or not the character is in the air. This will affect our animations as well. So B is in air. We're going to prefix our Booleans with a lowercase b. If you want to know more about that, I talk about that in my series Unreal Engine C++, the Ultimate Developer course. Next, we're going to create a Boolean called B is accelerating. And we'll simply use this to determine whether or not the character is standing still or moving. So we're going to give these some uProperty macros. For speed, I'm going to make this visible anywhere, blueprint read only. We don't want to be able to alter this from blueprints because this is going to be based on the character's physical movement. We're going to put this in the category of movement. And I'm also going to give it this meta allow private access equals true. I'm going to comment this and say the speed of the character. Now I would like our B is in air to have the same uProperty with the same specifiers, as well as B is accelerating. These are all going to have the same uProperty qualities. The comment for is in air will just say whether or not the character is in the air. And B is accelerating will say whether or not the character is moving. Now we need to get these values, and they're going to be changing from frame to frame. So that's why we're going to use update animation properties. Now we're going to be accessing shooter character. I know that we've used try get pawn owner and casted it and tried to populate shooter character, but we still need to make sure that that cast was a success. So we're going to say if shooter character. Now first we're going to get the speed of the character. So let's make a comment, get the speed of the character from velocity. Now we can get the character's velocity. It's going to be an f vector. So we'll create a local variable f vector velocity. We're going to initialize it with shooter character get velocity. Now we're going to zero out the velocity z component because we only want the lateral component of the velocity. So we're going to do velocity dot z equals 0. And finally, we can get a float that's the magnitude of this velocity vector. And that's what we want for our speed. So speed equals velocity dot size. So this speed value does not take the z component of the velocity into account. So if the character is flying upward or falling downward, that will not affect this speed variable. So we can even say in our comment, get the lateral speed of the character from velocity. Next, we want to populate the b is in air variable. So for the comment, we can say is the character in the air. And we'll say b is in air equals, and we're going to get the shooter character. We're going to call get character movement to get the character movement component. And the character movement component has a function called isFalling, which returns a Boolean, which is true if the character is falling and false if the character is not falling. Now, since we're using the character movement component, IntelliSense is going to yell at us until we include the character movement component header. So the character movement component is of type uCharacterMovementComponent, and I have the Unreal Engine documentation pulled up with uCharacterMovementComponent, and it tells us to include this header file. It's in GameFramework/CharacterMovementComponent. So I'll go ahead and copy that, and I'll paste that at the top of shooterAnimInstance.cpp. And that takes care of our IntelliSense error. Now finally, we want to populate our b is accelerating variable. So let's make a comment that says, is the character accelerating? So we can make an if check. And what are we going to check? We're going to check to see if the character's current acceleration vector has a size of 0. See, acceleration is a vector, and the size of a vector is its magnitude. So if the acceleration vector is 0, we're not accelerating. We can get that from the character movement component, which we can get from the shooter character. So we're going to say shooter character. From the shooter character, we're going to call get character movement to get the character movement component. From the character movement component, there's a getter for the current acceleration, and that's called get current acceleration. And from that vector, that's an f vector, we're going to get the f vector's size function. That'll get us the magnitude of the acceleration vector. And we're going to just check to see if this is greater than 0. Now, in this if statement, if the acceleration is greater than 0, we can set b is accelerating to true. But if this vector is not greater than 0, we can have an else case, and we'll set b is accelerating to false. Simple as that. Now, if you know a little bit about actual physics, I know what you might be thinking. Acceleration is only the change in velocity. So technically, you could be moving at a constant velocity and your acceleration would be 0 because your velocity isn't changing. But that doesn't mean your character isn't moving. Now, we're not going to adhere strictly to actual physics. This is just a term that we're going to be using for our game to determine whether or not the character is moving. So for our purposes, if the character is standing still, b is accelerating will be false. If the character is not standing still, in other words, it's moving around, b is accelerating will be true. So we'll just keep it simple like that. Okay, so we've created the shooter anim instance, and we've created a variable to hold a reference to the character. We've created the function native initialize animation, which works sort of like begin play, and we're going to use that to initialize shooter character by calling try_get_pawn_owner, casting it to a shooter character, and populating shooter character. We've also created variables for speed and whether or not the character is in the air and whether or not the character is moving, and we're populating those in update animation properties. We first check to see if the shooter character is null. If it is, we try_get_pawn_owner, cast a shooter character, and then populate shooter character. We then double check to make sure shooter character is not null before we access it. Then we use getVelocity from the character class to create a new local velocity vector. We zero out the z component of that, and then we get its magnitude with the f vector's size function. And we get that lateral speed float value and populate speed. We then populate B is in air by calling shooter character's getCharacterMovement function, which returns a uCharacterMovement component. We use that movement component to call isFalling, which returns a Boolean to tell us whether or not we're in the air. Finally, we check to see if our acceleration is greater than 0. We do this by getting our shooter character and calling getCharacterMovement. From the movement component, we call getCurrentAcceleration. That gives us a vector for our current acceleration. We then use the fvector's size function to return a float value that is the magnitude of our current acceleration. If that is greater than 0, we set our Boolean b is accelerating to true. If it's not greater than 0, we set b is accelerating to false. We can go ahead and compile this and make sure we don't have any errors. Now, I actually have a compilation failure, and you may have noticed my mistake when I made it, if you were paying close attention. When I added the meta allow private access specifier, I had a misspelling here. My typo was that I was missing an extra S here. It's ACCESS, so there needs to be an extra S there so it's spelled correctly. Fixing my typo, now I can compile. And now compilation is successful. Okay, we'll see you in the next video.